So we'll increase the difficulty level a little bit now. So I've got this scenario. How could carbon-13 NMR spectroscopy distinguish between propan-1-ol and propan-2-ol? Well, the best thing to do is to draw the displayed formulae, so then you can see the environment much more clearly. So if you want to have a think about that, and then I'll go through the answer. So there's the displayed formulae for propan-1-ol, propan-2-ol. So how many peaks would you see in the propan-1-ol carbon-13 spectrum? Well, each carbon is in a slightly different environment, and so therefore you would see 3 peaks. The propan-2-ol, the carbons at either end, they are equivalent to each other, and therefore they have the same environment. They're going to take the same amount of energy, or they'll absorb the same amount of energy when they resonate, and so you've got 2 environments, so 2 peaks in this one. So if we just have a think about what this spectrum would look like, and we'll sketch them up. So if we look at propan-1-ol first, so 3 peaks. What kind of environment have we got? We've got a carbon-to-carbon environment, so we're going to get something in this range here. Then we've got another carbon-to-carbon environment, and so we're going to see 2 peaks between, say, 10 and 50. So we'll put a couple of peaks close together there. So around about the 10 mark. And then this carbon environment here is carbon bonded to an oxygen, singly bonded to an oxygen, and that's that environment there. Hope you can see that on the camera. So C, single bond O, is sort of 50 up to 70. So we'll put that about there, 50. So your 3 peaks for that one. Whereas for propan-2-ol, you've got carbon-to-carbon environment, so somewhere we'll go for 10 again, and we'd have 1 peak in the C single bond O environment, so we'll go for 60 this time. So you could say, if you were interpreting your spectrum, you didn't know that, you could say, right, I've got carbon-carbon, carbon-carbon, carbon-oxygen, carbon-carbon, carbon-oxygen. So we'll finish with this one. We've got 2 aromatic compounds now. So remember, carbon-13 is only interested in the carbon atoms in the molecule. And so how do you think the spectra of these 2 molecules would differ? In other words, how many carbon environments have you got in each of those? So we'll deal with the molecule on the left first of all. So how many carbon environments have we got? Well, there's only 1 carbon bonded directly to an oxygen, so that's definitely 1 environment, so I'll colour that in red. And then these 2 environments here are actually equivalent to each other, and so we'll colour them in blue. The next 2 environments are equivalent to each other, so we'll colour those in green. And the carbon at the very bottom here is a unique environment. And so how many colours have we got? Got 1, 2, 3, 4. So there's 4 environments in this molecule. And so you'd see 4 peaks. We'll sketch the spectra in a moment. The other one, the one on the right, well, we've got this environment here, but that is also equivalent. And then all of the other carbons are actually equivalent to each other. So you've only got 2 environments on that one, and so you'd only get 2 peaks in this one. So if we just think about what the spectra would look like now, I'm going to use this A-level data sheet. It's probably not the most accurate data sheet in the world, but we've got essentially, we've got 2 environments. We've got carbon to carbon within a benzene ring, so that's going to be somewhere in this region here. So that means that the blue, the green and the orange, so we're going to get 3 peaks between 110 and just over 160. So if I go for, let's say that's 120 there, so we've got 1, 2, so there's 3 peaks in that environment. And then we've got a carbon bonded to an oxygen, which would be somewhere in this region, so what's that, about 70. So we'll go for that one there, whatever peak there. And then in this one here, we've got the greens, which are carbons in a benzene ring, so again about 120. So we've got 1 peak there now because these are all equivalent, and then the reds are equivalent, but they're in this environment here, and so we'll go about 60 this time. These are all very approximate, and a more accurate data sheet would give you far more accurate spectra. But for the purpose of the A-level exam, this is the data sheet that you use, and so that's what I've used in these molecules here.